pair of linear equation but in two variables. Two variables, which means two letters, two alphabets. Random, you can take two letters. Uh, let's say X and second Y. So these are two random letters. When we will take X, again X, then these are not two variables. So we will take what different two variables. So we can take what one X, second Y. Okay. So this was meaning of two variables. So here it is a very clear saying. What it is a very clear saying. You should have two linear equation. You would say where is the two? This pair, meaning of a pair is just two. So pair of linear equation. How much? Two linear equation. But both equation should be in two variables. So this one, this is the second variable, and we have to make this equation what? Linear. Now linear word is coming. Already you know definition of a linear equation. Linear. It is based on degree. It is based on degree. When degree is 1, then that polygon is what? Linear equation. If degree are 2, then that polygon is quadratic equation. But here we should have linear equation. And how much? 2. So pair of this. We will not write 30 plus m 60. No. Just pair of this. So variables should be same. This is x, then this should be same. Yeah. Coefficient numbers would be different. Here can be something else, here can be something else, and constant number can be something else. Okay, so this was meaning of this phrase. Now x is your variable, y is your variable, 5 is a constant. Let's understand this here in this. It is saying a is what? Coefficient. Already you know a is a coefficient, b is a coefficient. We would not say that a, b, c are what variables. No, here x and y are your variables, where a, b, c are real numbers. A, b, c are real numbers. When it comes to real numbers, then you can take any rational number, any integer number, any whole number, any natural number, even any irrational number. When it is coming to real number, then so rational and irrational number come in the category of real number. Okay. So here a, b, c are real numbers, but here here is what warning. A should not be equal to 0, whereas so b should not be equal to 0 as well. So here c can be 0. You can put c as a 0. But a and b should not be 0. Why? What is the logic behind it? It is saying if you put a 0 here, then this term will convert into 0. This term ax. So here this linear equation. This linear equation would not be linear equation. But as we know, we should have a linear equation in two variables. So that's why. If here except 0, whatever you want to put, you can put except 0. Okay, except 0 as a coefficient number. Then this will remain what? A linear equation. Except 0, whatever you will put in place of a coefficient number, then this linear equation would remain linear equation. but except 0. Okay, yes, c can be 0. C can be put it as a 0 according to question, according to that. From here we understood meaning of this and this. Here which means 2. Now you have a equation. From question we will understand the concept as well. Okay. This was the general form of this. You can say we have converted this statement in this form. This is the first question. No, question is what saying? What is the question saying? Question is saying uh, you have to show. You have to show. What to show? If you have given x as a 3 and y as a 2, then it is saying that this is a solution of this linear equation. We can't say that this is a pair. This is only one linear equation. So we have to show that when we will put x as a 3, y as a 2 in this linear equation, then this side will be equal to this side. Then we can say yes, after substituting this and this in this, it is a solution of x and y. Okay, after substituting, if LHS and RHS will not be equal to each other, then we would say that question was giving us x as a 3, y as a 2. Then this is not coming. This is not coming as a solution for this linear equation when LHS RHS will not be equal to. So after substituting this in this, then we will find that yeah, it is a solution or not. So 5, 3, 2. Okay, so 15 minus 6, 9. So yes, this is what LHS RHS is equals to each other. So we can say this is a solution of this linear equation. When we will put this okay, if you didn't understand yet, then if you put x as a 5 and y as a 16, y otherwise 7. Now after substituting this in this, you will not get yeah, you can say that this will not be answer for this. Otherwise you can say here x as a 5 here would not be x as a 5 if LHS RHS will not be equal to each other. When we will say that if after finding answer of x value of y value, we check how by substituting value of x, value of y. That's how we find answer is correct or not. So here after substituting this in this, in this linear equation, if LHS RHS would not be equal, then we would say these are not these are not those numbers that we will put, then both side will be equal to each other. 5 multiple 5 minus 3 multiple 7 is equal to 9. 25 21, so here 4 is equal to 9. You can see. So we would say this is correct, this is incorrect. This is not a solution for this. This is not a solution for this. So here this was coming. LHS, RHS are equal to each other. So we can say yes, this is the solution. This is the solution for this linear equation. You would say that this is the value of x, this is the value of x, and this is the value of y, which is answer of x and y of this linear equation. This is the exact answer. Okay, and here these are not exact answer for this linear equation, because we after substituting this, we didn't get what LHS is equals to RHS. That's why these are not exact value of x and value of y. That's why. Now graphically, let's see graphically. Graphically. Here, as we know, uh, this y is what? Vertical, and this x is horizontal. X is line which is horizontal, y is a line which is vertical. Now, from this graphical, we are understanding linear equation. When it comes to linear equation, we know that it has an infinite solution. It has infinite solution. But when it comes to pair of linear equation, then there would be some conditions. There would be some condition. Now, if already we know linear equation makes a straight line on graph. So if we will have what, two linear equations. So of course we will have two straight lines. So one linear equation is making like that, and one like that. So here, this both are the straight line of a pair of linear equation. So here, these two lines are parallel to each other. So first pair of linear equation can make this type of a figure. Now second type of pair of linear equation can be like that. So after finding solutions, so two lines of a pair of linear equation will be like that, can be like that. So this is what overlapping of one line to the another line. So this is one. So we can get this type of a figure sometimes. We will get this type of a figure sometimes. We don't know when we will get. But here we are understanding, yeah, we will get three types of figure of a pair of linear equation. So first we saw this, and second. So first was what? two lines are parallel to each other, and this secant is what overlapping to each other. So one is a overlap on another line, and third would be what, like that, like that. You cannot say that these two lines are parallel to each other. No, no. Again, I am telling you why. Parallel lines do not intersect to each other. Is the meaning of a parallel lines. So parallel lines will not be intersected to each other. Never, never will, never this two lines will not. Never these two lines will intersect to each other. Okay, after extending. But these two lines will intersect to each other. After intersecting, you can see, yeah. So here these two lines are intersecting, but these two lines will not intersect anyhow, anytime, any point, at any point. So we can say this is a parallel line, but this is not parallel lines. Instead of saying this is a parallel line, we would say what? Yeah, this is a non-parallel line. So here we have a three figure of a pair of a linear equation, and this type of figure we will get when we will find solution of linear equation. There we will discuss more regarding this. This was just a little information about it. So from here you understood we can get three type of linear line, three type of linear line of pair of linear equation. First, which is a parallel line. Second, which is overlapping to each other. Third, which is a non-parallel lines. From this understanding, you will understand what consistent, inconsistent, infinity solution, unique solution. I don't know when will be unique solution. So just have a look. So here, this parallel will be inconsistent. Consistent. And this will be consistent, and this will be consistent. So parallel lines will be inconsistent. Now let's understand this. This is also consistent. Now, how much solutions can be found from from this type of lines? So here, this is consistent, this is consistent, this is inconsistent. Now, these are what? Separate to each other. So we would say this equation is not giving us any solution. So you would say no solution, no solution, no solution. Here you can see this is giving us a point. This is giving us a point which is at intersecting here. So here you would say what this is unique solution, because when two lines will intersect to each other, then there will be form a intersection view, and that intersection view will be at a point, and that point will form a what? A unique solution. If there is one point after intersecting by two lines, then that point is what? will give us a linear a solution. If there are not what if there are not any if there is no intersection view of two lines, then we can say there would not be any solution, because of parallel lines are not intersecting to each other. That's why that parallel line will not give a any solution from a linear equation. And this is consistent. Now you can say one is just on another. One is just one line which is on another line. So this is a forming a line after overlapping. So here you can see there are infinity points. That's why we would say, yeah, this lines will give what infinity solutions. When it comes to overlapping, then you have to think, yeah, there would be many points. So overlapping will make a lot of solutions. But okay, this was consistent, this was also consistent, but here two lines are intersecting, so of course there will be only one point after intersecting, and that point is making a unique solution. That point is what? Intersection with, no, here parallel lines. So here, as we know, parallel lines will not intersect to each other. Parallel lines do not intersect to each other. So of course there will not be any point from parallel lines. That's why from that parallel lines will not be what any solution. Here you can see. We have a question based on this understanding. We have to solve this linear equation as on graphically. I am erasing this side so that we can solve equations. From this understanding, we understood that how much solutions can be found by two pair lines. Now this is saying what? As we do, we will do. As we do, we will do. So after finding, we have in ninth standard we were solving only one linear equation. Now in this we will be solving two linear equation, and then we will make two box for two linear equation. Then we will draw what countation plane, otherwise you can say graph, and we will plot a two linear equation, solution of a two linear equation on graph. Then we will find two linear line. Then we will say what is how do lines look if lines look as a parallel line. Then first let's So x plus y is equal to 3. Here, from here you have to do is that just shift all things. Just put a variable in one side, only one, and apart and except one, all things shift in another side. So only one variable we are taking in one side. So 3 is this side, and we are shifting this by this side. Okay. Now from here, this is one solution of a linear equation. Now second is this. So this will become this. Now let's make a box for this. For this x, y, and for this x, y. Okay, x, y. Now we will start from 0. You can start from anywhere. It's your choice. So if I put y as a 0, then x will be what? 2, no, 3, 3, 1, 2. Okay, 1, then 2, 2, then 1. Here y as a 0, then x will be 1, x will be 1. Y as a 1, then this will be 2, this will be 3. We have found solution, 3 solutions. We have found 3 solutions of a pair of linear equation. Now we are drawing a, look at this. From here you will get clarity. 1, 2, 3, 4. One, two, three, 4, 5, 6, 7. This is y, this is x. Okay. Now we will plot all coordinates on this graph. So here y is 0. So okay, y is 0. X is 3. So this is here. One point is here. Okay, one point is here. So y is 1, and 2 is as a x. So this okay, this second point is here. Third, x is 1 and y is 2. So third point is here. So we are getting what? A linear line. We are getting a straight line after drawing a. So this line is containing all 3 points. So this line you can see. Okay. Now second this x is as a 1. Okay, this. So one point is here. Okay. Next is what? Y as a 0. Okay. One point is here. Y is as a 1. This. And x as a 2. So this is second point is coming exact over here. Now third, y is as a 2. So y 2 where? 2 here. And x 3. So this is coming over here. Now we can draw a straight line which will contain all 3 points. Now we have 2 straight lines in which both lines are containing their 3 points. So here, can you tell me, is this forming parallel lines? Not. No. Both lines are intersecting to each other. So both lines are non-parallel, not a parallel. Okay, so both lines are parallel, so we would say this is a consistent. Okay, this is consistent. Now this is consistent. Here we are getting what, extra one point. We are getting extra one point, which is here as a 2 comma a 1, 2 comma 1. This extra point which is at the intersecting place. So here we are getting only one solution, only one solution. So we would say there is a what, unique solution, unique solution, unique solution. So here from this linear equation, from minimum this is what, understand carefully. So this you have to this linear equation, whatever you want to find 10 solutions from this given pair of linear equation, you find, okay, you find 10 solutions uh, for both linear equation. Then again still you will get what, still you will get this 2 comma 1, this again, okay, again. So all points will be like that, okay, all points will be on this line, all points will be on this line, but intersecting view will be here, which is only one, and which is only one solution, which is what, how much, 2 comma 1. So it doesn't matter if you want to find, you can find the 100 solutions from this linear equation, but you would get only one unique solution, which would be always what, 2 comma 1. This is what we understood from this. So when there is a one point, extra one point after intersecting by two lines, then there would be only one unique solution. That's all you solve. Now we are understanding, we are going to understand such methods of solving pair of linear equation. First method is substitution method. Substitution method. By taking equation, we can understand meaning of substitution method. We will apply this method in linear equations. And writing equation. This is question, and we have to apply substitution method. Substitution method says we might have heard this word many times in our lectures, and meaning of substitution is the same. What, just we will find what value of one variable. We will find value of one variable from one linear equation. Then we will put a value of that variable in another equation, in another linear equation. So here we will work what? We will be substituting value of one variable in another equation. That's all. Okay, that's all. You can see here. We have how much? Equation is saying you have to find value of x and value of y. Using substitutions we will use. Don't worry. So we have a two linear equation. So first is a 2x plus y is equal to 7. First we will solve this. Only we will put a variable in one side and all things we will shift in another side. So y, let's state this y as a single. Okay, 7 as it minus 2x. So here second 4x minus 3y plus 1 as a 0. So here 4x minus 1 and this is what? Plus 3y. So it will be minus 1 plus 3y upon 4. Okay. Now what can we do? Here we will put this value in this, and this is what is a substitution method. We are substituting value of this single variable in this equation. Even you can put a value of this in this equation. So it's your choice. It's your choice. Now I am putting one thing. What? This in this equation. So we can say this was one and this was second equation. This is a third and this is a fourth. So that we can identify easily. So here we are putting y in 4. Okay, y in 4. So x minus 1, okay, plus 3 multiple, and this is what? 7 minus 2x upon 4. We will simplify it. So it will become 21 plus 21 and minus 6x upon 4. So this is how much? 25, and this will come this side, x plus 6x upon 4. Here we will do what? Cross multiple. So 4x plus 24x is equal to 25. Clear? 4 is common. X plus so this is how much? 28x upon 25. So here 25 upon 28. That's how it is becoming. So here we did wrong. Here we are wrong. We will put this value in this in second equation. So y in second equation, 4x minus 3, 7 minus 2x plus y plus 1 is equal to 0. 4x 21 plus 6x plus 1 0. So this 6 4 10, so it will be 20. So x 20 upon 10, x is a 2. Now we will put this this will the value of this x in third equation. So x in third equation, okay, x in third equation. From this equation we will get value of y. So value of x get now, okay, 7 minus 2 multiple 2. So 7 minus 4, it is how much? 5. So finally we have y as a 5 and x as a 2, you can see. Okay, that's how you will solve any pair of linear equation by using substitution method. That's all. Next question we have this is question. We will solve this question by using substitution method. First, let's simplify this. First is what 3x upon 2 5y upon 3 minus 2. This is first. So here 3 2 is 6, 2 3 is so 3 3 is 9x, 3 2 is 5 2 is 10 minus 2. So 9x minus 10y minus 12. Okay, this is third. This is second equation. We cannot take anything common as a common. We have simplified this in simple loop. Okay, in simple loop. We have next what? X upon 3 y upon 2 is equal to 13 upon 6. 13 upon 6. 3 to the 6. Okay. Here 2x plus 3y. So 6 will get cancelled out. We got what 2x plus 3y is equal to 13. This is the third equation. Hold on. This was third equation, and now this is a fourth equation. This is fourth equation. Now from here we will find what value of one variable. Let's say 9x, okay, minus 12, and this is 10y. So we will shift this in this side. X minus 12 plus 10y upon 9. We will substitute this value in this. So here you can see x in equation 4. X in equation 4. Okay. Now x in equation 4. So 2 multiple minus 12 plus 10y upon 9. plus 3y is equal to 13. So minus 24 plus 20y upon 9. 3y is equal to 13. So here, no, this is 13. Okay. Okay, here minus 24 minus 24. So can we write this as 1? We are taking no as LCM. So this will be as it 20y. So here this is a plus and 9 3s are 27y is equal to 13. Now we have what? Minus 24. So can we write 20y? So it will be 57y and 9 3s are 27, 2, 9 to 11 and plus 24. So y 1 3 4 1 upon 57. Y is as a 57. So 57 multiple 3. 1 2 3 5s are 15. 3 5s are 15 and 7. So y came as a 100. So here this is 47. This is 47. Now 47 multiple 3. 1 and 4 3 is 12. 12 14. So this will get cancelled by 3. Y is 3. Now we will what? We will do one thing more. Is that just put a value of y in this equation. Okay. So here x is equal to minus 12 plus 10 multiple 3 upon 9. So from here we will get value of x. Okay, minus 12. So 30 upon 9. So 13 minus, so 18 I think 18. 10, 20, 30 upon 9. 9 to is 18, so x is as a 2. Okay, x as a 2. So finally we can say x came as a 2, y came as a 3. So that's how you will simplify fraction terms of linear equation. Then you will, after simplifying fraction terms of linear equation, you will apply substitution method. Just you will find value of one variable, then put a value of that variable in second equation. That's all. Now we will have some questions. We will solve now upcoming questions by using elimination method. Before that, we will understand uh, meaning of elimination method. So I am erasing it. Elimination method. We have equation. This is the first question. We have to solve this question by using elimination method. Now, elimination method says that just you have to make a pair of a variable equally. So first is 10x plus 3y is equal to 75, and second is what, 6x minus 5 is equal to 11. Now only one variable, pair of one variable, you will make equally to each other by multiplying. It will happen, it will be possible by multiplying. So we will multiply whatever you want, take a number for multiple these two linear equation, then you will multiple both sides. For example, I want to make this pair of y equal to each other. Then I will multiply this by 5 and this by 3, just opposite. And this is 3 and we will multiply this equation by 5 and we will multiply this equation by 3. Okay, goal. Okay, goal. In both sides, but in both sides. Now 50x plus 15y, 5 5s are and 7 5s are 35, 37. Okay, now 6 3s are 18x minus 15y, 33. Okay, now from here you will subtract, or you will either subtract or add. If you are adding, then here you can see we got what, this y with the coefficient equally. Okay, equally we got y with the coefficient equally, and that's what we wanted and we got. Now here operators with both terms are different. So from here, if you are adding, then it will get cancelled out. It will get cancelled out. Now how much we have? 8 6 x, okay, and this side is what, 8 0 and 4 4. Now here you can see this will be plus, okay. If operators are different, operators of this are different, then we will add all terms. If operators are same, then we will subtract. So here 408 upon 68. Till here, is it correct or not? No. Yes. Till here it is correct, and this will cut this by 6. So x is 6. Now x is a 6. We will put x value of x in any equation. In any equation. Okay, here we are putting. You can say we are substituting value of x in this equation, in second equation. 6 multiple 6, 5, y is equal to 1. 36 minus 5y is equal to 11. Here minus 5y and 11 minus 36, 5y. So here it is what, 36, 11, 5, 2. So of course minus 25, and this is minus. Y is equal to minus 25 upon minus 5. Minus will get cancelled out. So overall we will get what, y as a 5. So x is as a 6, y is as a 5. Now, so we have applied elimination method here. So meaning of elimination method is what? Just we will multiply in both sides of the linear equation to make a pair of a variable equal to each other, so that we can get value of one variable. So here is what we have applied elimination method. Then after applying elimination method, we simplified each equation. Then we found x as a 6, y as a 5. You can see here. So from this equation we understood how to apply elimination method. Next question, but next question is different from this question. So finally we have this question. We will apply elimination method, but before that we will simplify. We will remove what, decimal from both the linear equation. How to do? How to do? How to remove a decimal in both? So can we say after multiplying 10, 10, 10, 10, 10, 10, 10. Yes, after multiplying. So here you will write after multiplying 10. Otherwise you can say I am writing directly after multiplying after multiplying 10 in both equation. You understand? Okay. So here this will become 4x minus 15y is equal to 65. This is 1. Let's say this is 1. Next 3x plus 2y is equal to 9. This is second. This is second. Okay. Now what else? What else? Now we will apply elimination method. So you can make this variable, this pair of y variable equally to each other. It's your choice. So I am multiplying this by 3 and this by 4. So how will you do? So we are multiplying this, so we will multiply by 3 by this in this equation. So let's write value of x minus 5, and it is wrong. 30, 25. What is happening? 3 5s and 3. So yes. So here 3 5s and 1. So 18 and 19. Okay, clear. Clear. Now 4 3 is 12x. So here this is plus 4 2 is 8 y. This was y. Now 36. Okay. So here we have what same operators. We have same operators. So we will subtract. This will get cancelled out. We will subtract. When it comes to subtraction, then this we will not observe here. So here is a addition. We will apply what subtraction. Now here this minus and we will add both. So 45 and 8 will be what 53 y. Okay, and here plus minus. So we will subtract this from this. So here is what 9 and here is what 18. So we have 59. We got what? We got 159 upon minus 53. After cancel out this, we will get so here 53 by 3. 3 3 is 9. So 3 5s are 15. 3 5s are 15. So by 3. So here this will cut this by 3. So we got y as a 3. Now we will substitute a value of y in any equation. So 3 multiple x. So we are substituting y. So 2 multiple minus 3 is equal to 9. We will simplify it further. So this will be 6 9. 9 plus 6 upon 3. So this is 15 upon 3. 3 5s are 15. X as a 5. Okay. So finally x as a 5, y as a minus 3. Can you make a coordinate from this? Yes, 5 comma minus 3, like that. Coordinate. So finally, this is answer. This is answer.